From the labyrinth of loops to the variable valley, we'll see the cliffs of value first. JavaScript's right up your alley. Built-ins, bluff, file spas, array, archipelago. Declarations in a desert where you'll find out how far you'll go. Learn to program, take a ride, buy a ticket, step inside. All aboard, you're at the station to increase your education. Bon voyage, skinny dip! As long as functions you don't skip on this, the JavaScript road trip.
Ever have one of your programs produce errors, not because your logic or your problem-solving design is incorrect necessarily, but instead because the load order of the functionality within your website seems to be getting in the way of your success? Turns out, load order is a very important thing in JavaScript, especially when parts of your program rely on other parts very heavily to succeed, but can't find those parts exactly when they need them. Now, this level may seem a little short, but don't let that deceive you, because this packs on a very important bit of broader perspective for you as a developer. And with that, enjoy your hike in the hoisting hills. Hey guys, welcome back to Level 3. This is the hoisting hills. Now, in JavaScript, hoisting is not something that you do. It's just something we want to make you aware of. It's a concept about program load order. So let's take a look at this program right here. Now you can see it's got 3 functions in it, as well as 2 global variables. And within that, function 2 is going to call 2 subfunctions as well as initialize another local variable inside function 2's scope. If all the stuff that's in function 2 works okay, then function 2 will be great. And then, if everything in the global scope works all right, then our program will be just fine. Sometimes, though, in the process of coding, we produce a code order that doesn't produce a correct output because of the way that JavaScript prioritizes the loading of variables and functions into memory. So now we're going to look at the load order in tandem with this concept called hoisting. For example, if in our function 2, local variable 1 needs subfunction 2 for something, but it's not loaded yet, then local variable 1 will fail. And ultimately function 2 would fail. And if function 2 is failing and our entire program depends upon it, then our program fails too. So we're going to look at this load order concept, a concept we call hoisting, so that you can always be sure that your programs run correctly. So think about when we initially open a scope in JavaScript. The first thing that's going to happen inside that scope is that memory is going to be set aside for all of the necessary variables and the declared functions that the compiler sees within the scope you have built. So let's take as an example this sum of squares function that you can see we've built here. Inside it, you see the variable x being declared and then assigned a value that comes back from an add function. And then that variable is returned. Towards the end of the scope, you can see the add function being declared just as a regular declared function. Now that's what we see in our code when we write it. But let's look at how JavaScript actually sees it when the compiler runs the program. So the first thing that happens is that the variable x is hoisted to the top. It's given memory space at the very beginning of the scope initialization. But it has no value. The very first value that it has is undefined. The next thing that happens is the whole declared function is hoisted to the top of the scope and sits there in memory waiting for us to use it. And then, and only then, the executable code, the stuff that we actually want our function to do, that's when that gets run. Now this is a great example of a function that works exactly as we would want it to work when it loads and when it runs. But let's take a look at a few examples where hoisting has not quite the impact we would expect. So first here we're going to build a function called getMysteryNumber. And inside that function, we've first declared a function called chooseMystery, and it's going to return 12. And then following that, we're just going to say return the result of the chooseMystery function. Then after that, you can see I've declared another function called chooseMystery again, and that returns 7. So if we were to call getMysteryNumber, what do you think happens in this case? A little tricky. So all of this code loads like this in the compiler. The first thing that happens is The very first declared function gets hoisted all the way to the top. That's the first choose mystery. But then the lower choose mystery, the one at the bottom of the code, gets hoisted also to be the second function in line. When that happens, the original choose mystery function is completely overwritten. It is no longer there. Then the final and only executable statement says return the result of calling choose mystery. So what's actually going to happen here when we call get mystery number? We get a 7. Again, this is the case because all of the functions have been hoisted up to the top, and then one was redefined. It's completely gone because of the second function. Let's take a look at another build of the get mystery number function. This one's going to involve function expressions. Now, something to note here is that function expressions are never hoisted. They are always treated as assignments. So let's take a look. First thing I got here is a variable called choose mystery, and I'm assigning to it a function expression that returns 12. Following that, here's my executable statement, the return statement of choose mystery. And then after that, another function expression that's also called choose mystery in the variable, but that one returns 7. What do you think will happen now when we call the get mystery number function? Well, here's how JavaScript loads it. The first thing that happens is the variable choose mystery is hoisted to the top and memory space is provided for it, and the value is set to undefined. So JavaScript has no idea right now whether that's going to be a number, a string, an array, or a function expression. Following that, the second variable declaration of choose mystery is hoisted to the top, which is also undefined, and that completely overwrites the other choose mystery variable that was undefined. Then we arrive at an executable statement. That is, when the choose mystery variable gets assigned a function expression, this one returning 12. Following that, we see the executable statement return choose mystery. And so this function is going to terminate at this line. It's actually going to call the choose mystery function right now. And then this later assignment of a function expression to the choose mystery variable is actually unreachable as a result of that return statement. So again, once we've returned, we can never reach that code that's underneath the return statement. So when we call get mystery number, the only function expression that's ever been associated with choose mystery by the time we return is the one that returns 12. Okay, so let's shuffle around the build a little bit and see how hoisting might impact this situation. What if we move the return statement up to the top? That's the very first thing that our function sees. And then we put our two expressions, our two function expression assignments, down underneath the return statement. What do you think the get mystery number function will return in this case? Let's take a look. So the first thing that happens is the first variable that's ever declared, which is the first choose mystery you see on the left, that gets hoisted to the top and it's assigned an undefined value. Same thing happens for the second choose mystery variable, and the first one is gone. It's completely overwritten. Then we tackle the return choose mystery statement, because that's the first executable code in our function. But there's a problem. Because check it out. After that return statement, both of the choose mystery assignments are completely unreachable because the function thinks, oh, well, I'm just going to return and call this random choose mystery variable that he's assigned. And as a result, we get an error. So this function does not complete at all and never returns anything that we would want it to return, neither 12 nor 7. So remember our train system from our road trips 1 and 2? Let's take a look at how hoisting might impact a capacity status function for the JavaScript Express. So we will build a capacity status function that takes in the current number of passengers on the train, as well as the capacity for the train. Then, if the train is full, we want to execute a function here that alerts a message that says no seats remain and then returns us a false, so we know that we don't have any seats left. Next, if the train is not full, We want to execute a function that alerts a message with how many seats actually do remain, and then returns true. So what would this look like in code? Well, we would say if the number of passengers currently equals the capacity, that means we've got a full train, then we'll call a function called noSeats. Now we haven't defined that yet, but we will in a bit. Otherwise, well, if the number of passengers doesn't equal the capacity, we know we have some seats remaining. So we'll call a function now called seatsAvail, and that will tell how many seats are available. Now let's work on those particular functions. First, we'll look at noSeats. What if we, in our normal coding process, just started to assign a noSeats variable a function expression? And we said alert, no seats left, and then we return to false. Next, if we did the same thing on the seatsAvail function, and we just assigned a function expression to the seatsAvail variable, inside the seatsAvail function, we would just alert a message that tells us how many seats are left for passengers. And that function would return true. So now let's test this out. What if we called capacity status with 60 and 60? That means we have a capacity of 60 on our train, as well as the train is full. We have 60 passengers. So let's trace our code and see what the hoisting does in this case. The first thing that happens is the two variables that will eventually get function expressions are hoisted to the top, and they will have undefined values. After those variables are hoisted, we have the whole slew of executable code. The first part is the conditional statements. If we have the same amount of passengers as capacity, we'll call noSeats. Otherwise, we'll call seatsAvail. Following that happens the assignment of the function expressions. That's when noSeats and seatsAvail actually get their functions. So, do you already see the problem? Hopefully you already see the problem here. Because when we get to if the number of passengers equals the capacity, we will get a true on that because it is true that our capacity does equal our number of passengers. And then the compiler will call noSeats. But it doesn't even exist yet by the time that it is called. So this function will completely error out and we will not have any message at all. So, well, we now know that hoisting causes problems. What can we do to fix these problems? A couple ways. Let's take a look at one. First thing we could do is actually change the order of our code. If we push all the variable declarations and their assignments north up to the top and all of the conditional code down to the bottom, the variable declarations will happen in the hoisting, as well as the assignments will happen directly after that. So if we look at that capacity status test case again with 60 and 60, the first thing that happens is the variables get hoisted to the top. They're both undefined, but the cool thing here is that they immediately get assigned their expressions. Woohoo, we like that. And then the conditional code is all the way at the bottom, so we don't have to worry about any execution until everything's hoisted, all the assignments are made, and then we can make an execution. So now, when we check to see if num passengers equals a capacity, it still does. But this time when we call noSeats, everything's fine. There's a function in the noSeats variable, and we're good to roll. And we get our nice alert message. No seats left. Second way to fix this particular hoisting problem would be to not have function expressions at all. Instead, we could have declared functions. We're going to try another test case here. We're going to put 20 in so that we can see how the else part of our conditional works. Because in this case, what? The number of passengers will not equal the capacity. And let's see what happens in the hoisting of this situation. First thing, all the functions pop up to the top. They are loaded into memory and sit there waiting for us to use them. Again, the conditionals fall to the bottom because they are the executable portion of the code. Then we'll get a check to see if the number of passengers is equal to the capacity. In our new case, it is not. And so we will skip that if statement. And we'll head straight to the else, and we will call seatsAvail, and guess what? seatsAvail is already in memory. We'll get a very nice status that says there are 40 seats left. That's because 60 minus 20 is 40 all day. This was kind of a short level, but we wanted to make sure that you understand Hoisting is not something you do as you code. It's something that sort of happens to you on the back end when your programs get loaded. So be very careful as you code, and we're going to send you to some challenges now to make sure you understand the hoisting concepts well. See you soon. If I have the puberty thing, because it will pop out. Think about what you think. JavaScript's road trips, 1 cent.